Hello again. As I promised you in the last video clip, we could have a look at actually question 18 that we started looking at last time. So I want to share my screen with you and see how that goes. Make that down a bit, put that away somewhere. Right. Good. And here's the question that we were looking at. I go over to my other camera, my document camera, and see what we find here. We've got a situation where, let's look at the information that we're given. We've got triangle scenario. LMN is a right angle triangle. Okay, LMN. There's the right angle, we can see it, and then he tells us, as our eyes go down the page a little bit and we see the angle NLM equals 90 degrees, NLM 90 degree angle. So that's twice he has told us this piece of information. So seems to be useful. He didn't want us to forget the top line, so he's told us again here. Then he tells us PQ is parallel to LM. So line PQ up there, parallel to LM. So what is the significance of that? The area of triangle PNQ is 8, PNQ. So we're told that that little triangle in there is 8 cm squared, and the area of the bigger triangle, slightly bigger, not massively bigger, it's not the biggest of all the triangles, is 16 cm squared. Okay, fair enough. So the area, so we're told the areas of these two triangles, and we're asked to work out the area of triangle LQM. LQM. So okay, we're being asked to find the area of this triangle. And from the information that we've been given, it would seem that it might be a good idea, because he's asking us to think about these two smaller triangles and work our way towards this wanted triangle. So, okay, our first reaction might be to say, well, haven't a clue really at first, as is often the case in maths questions. So when that happens, we're not too sure what to do. We, first of all, read the information very carefully again, and then we probably do whatever we can, do something sensible with that information. So looking at the information again, we come back to the business about PQ is parallel to LM. Question is, why has he told us, and he's indicated on the lines, he's indicated by these little arrows, that the two lines are parallel? How can we use that information? Well, we can say, what do we know about parallel lines? And lines that are cutting parallel lines. It would mean that the right angle triangle that he gave us before, then this angle up above here is a right angle as well. Both are 90 degrees. And here we have another line that's cutting the two parallel lines, which would mean that this angle is going to be the same as that angle. So those two angles are equal to each other. And then the third angle up in this triangle, if I just put two little marks on. So we're getting to a situation where I think perhaps similar triangles might play an important part in this, because he's given us the area of one triangle is 8 and the other triangle is twice the size. So we're trying, I think, to find the area of the big triangle. If we could find the area of the big triangle and then take away the areas of the small triangles, that might be a useful thing to do. That would be one way of getting towards the answer. Get the area of the big triangle, because all we've got to do then is subtract the two small triangles from it. Hopefully, by this stage, we're starting to see that similar triangles are going to be involved. We've got the small triangle up at the top and the big triangle down below. So if we look at the situation that we have there, I drew these earlier, should be able to see that this angle in the small triangle is the same angle in the big triangle. We've got the right angle in the small triangle, and we've got the right angle in the big triangle, and we've already agreed that that angle and that angle are the same size. So we're dealing with similar triangles. Let's look again at the area of triangle PNQ, P to N to Q, and we're told that that is 8. Now the area of a triangle, so triangle is of course 1/2 the base times the height. And in the case of PNQ, so that's 8, so that's going to be 1/2. We'd call the base PQ if you like. PQ times the height of it, which is PN. And it has to, of course, be the perpendicular height. And that's exactly what we have there in PN. PN is the perpendicular height. And we're told that that is 8. For the triangle PNQ. For the triangle LPQ, let's have a look at L to P to Q. L to P to Q is this little triangle here. And so the area of that would be 1/2 times the height, which would be, and sorry, 1/2 times the base. We can call PQ the base again. PQ multiplied by the height this time is P to L. And we can put that equal to 16. And by figuring this out, I hope we will see that PL has to be twice as big as PN. So P to PL is twice the length of PN. So going to our diagram, where we see PL is, if that's 2, I'm not saying, well, so the ratio of, so PN is in the ratio of 1 to 2. So these two sides, these two bits of the little triangles, are in the ratio 1 to 2. Well, we would really like to get a comparison between these two triangles. And by thinking about it carefully, if PN is 1, then all the way from N down to L would be 3. N down to L would be 3. So our similar triangles then, story. So for similar triangles, the enlargement scale factor, linear scale factor, is equal to times 3. Okay, so the sides in the bigger triangle, so NL is 3 times the length of NP, N to M is 3 times the length of N to Q, and L to M is 3 times the length of P to Q. So all the lengths in the big triangle, all the sides, all the linear bits are 3 times the lengths in the smaller triangle. Okay, Now that brings us, of course, to an area scale factor, because the areas are what we're really interested in. So we have to remember that if the linear scale factor is times 3, then the area scale factor is times 3 squared, which is times 9. And of course, if we were to go to a volume scale factor, the volume scale factor would be 3 to the power of 3, which would be 27. But we just need to, so for this question, we just need to go to the area scale factors times 9. So now, let me think a moment. So the area of the big triangle, now the area of the small triangle was that area we were told was 8. We were told that that area is 8. So therefore the area of the big triangle, therefore of triangle NLM is equal to 9 times the 8, which turns out to be 72, CM2. Take away the 8 and take away the 16. Take away the 8, take away the 16, leaves us with the area of LQM, which is what we want. Is 72, take away 8, take away 16, and that should end up giving us whatever the answer is going to be. I think it's going to give us 48 CM2. Yes, that will agree with the mark scheme. So now we had to work out and get the 48, but there's quite a lot of processing to be done. We had to figure out that the area of the bigger, you see that here we've got the 8 multiplied by 2 plus 1, 3 squared. This is your area scale, this is your linear scale factor inside the brackets, and then squaring it to get the area scale factor to work our way up to 72. Then take away the 2 smaller areas, and that gives us the final answer. Okay, so that's it for now. So thank you very much. Do the usual things with that. Like it, please, and of course, share it with your friends if you haven't got any, and then of course go make some of those, and hope to see you next time. Bye.